the measures of the smallest angles of three different right triangles sum to 90 degrees. All three triangles have side lengths that are primitive Pythagorean triples. Two of them are 3, 4, 5, and 5, 12, 13. What is the perimeter of the third triangle? Let's tackle this. So we've got one triangle, we got another triangle, and we got another triangle, right? So the first one they're saying is a 3, 4, 5. So 3, 4, 5. The next one is a 5, 12, 13. And the last one, we don't know. Okay, so then we have to find three angles. So let me just put them in. Angle B, angle A, angle B, angle C. So this angle, and that angle. And those three angles total 90 degrees. Okay. And any other information? I think that's it. They want me to figure out the perimeter of this guy right here. Okay. So using trigonometry, this, let's see here, what should I use? I'll go with tan. Tan of A looks to me like 3 over 4. And here the tan of B looks like 5 over 12. Correct? Okay. And then we're going to have to use a trig identity, but fortunately it's not one that's that difficult to remember. It's one of the more common ones. It's tan of A plus B. And tan of A plus B is the tan of A plus the tan of B over 1 minus the tan of A tan B. Yeah. Okay, so using this and this, we will put that in. So the tan of A plus B would be the tan of A, which is 3 over 4, plus the tan of B, which is 5 over 12, plus 1 minus 3 over 4 times 5 over 12. And when you crunch out these numbers, you get 56 over 33. All right. I think that's pretty decent progress so far. Now we are going to start to include C now. So we're going to do tan of A plus B plus C. That whole thing. And that is the equivalent of the tan of 90, correct? Because A plus B plus C is equal to 90. So the tan of 90, I believe, is undefined. Undefined. So let's use this formula over here on this guy. So the tan of A plus B, I purposely put it in brackets because that's going to be our first angle, and C would be our second angle. So that's going to be written like this: tan of A plus B plus the tan of C, and over 1 minus the tan of A plus B times the tan of C. Okay, so we concluded that it's undefined. So the only way that's undefined is if the denominator is equal to 0. So that means that 1 minus tan of A plus B times the tan of C is equal to 0. Okay, so that's pretty decent. So let's solve this. So that means the tan of A plus B times the tan of C. Tan of A plus B, we actually got 56 over 33. So let's plug that in, 56 over 33, tan of C. And therefore the tan of C is equal to 33 over 56. So we can now revisit that triangle, right triangle, that's C. The tan is the opposite over adjacent. So this is 33, this is 56, and this is the hypotenuse. Using Pythagoras, we can easily figure out the hypotenuse, right? And then when you solve that, you will get H equals to 65, and therefore the perimeter would be 33 plus 56 plus 65, and that is 154. 154 is the answer, and that would be C. Let triangle ABC be a triangle with integer side lengths, and the property that angle B is equal to 2 of angle A. What is the least possible perimeter of such a triangle? Let's draw a triangle. And let's try to explain this. So let's label this A, B, and C. And that is an important fact. So this will be theta. And then I guess angle B is 2 theta. And I'm going to... Okay, I'm going to use the angle bisector theorem. So first let me explain the theorem just in case you have forgotten. So let's say you have a triangle like this, and you have the angle kind of split. So this is theta and this is theta, right? We've bisected the angle. And this side is labeled A, this side is B. From here to here is X, and from the other side there to there is Y. The angle bisector theorem states that A over B is equal to X over Y. So we're going to do that here. We're going to bisect this angle B and make it theta and theta, because remember B is equal to 2 theta according to that up there. Okay, and then we obviously need to label some stuff here. So from there to there I'll label M, and from there to there I'll label N. And using the angle bisector theorem, okay, I need to label the sides. I'll label this side small a, small c, and small b. So using the angle bisector theorem, let's see, what do I get? I get A over C is equal to M over N. And also M plus N is equal to B. And therefore, if I use this guy cross multiply, I get AN is equal to MC. And N is equal to M over C over A. And so far, that's about all I can do. Okay, now let's revisit this triangle. I'm going to see if I get work a little bit more with this triangle here. This angle in here looks to me like 90 minus 2 theta. Hold on, let me think about that for a second. Oh, sorry, 180 by minus 2 theta. Yeah, 180 minus 2 theta. That angle. And then this angle, therefore, would be 2 theta. Yeah. And then this angle would be 180 minus 3 theta. 180 minus 3 theta. So there should be a similar triangle situation here. Triangle B. Oh boy, I'm going to have to label this something. Let's call it P, because I have to label that triangle. BPC is similar to the whole thing, ABC, because they have the same angles, right? ABC, the angles would be theta, 2 theta, and 180 minus 3 theta. And BPC has angles theta, 2 theta, and 180 minus 3 theta. So perfect. So using similar triangles, that means that M over A is the same as A over B. Yeah, let's see. M is the 2 theta, 180 minus 3 theta side in the small triangle, and in the big triangle, A is the, let's see here, 2 theta minus, the 2 theta and 180 minus 3 theta. In the small triangle, A is the theta, 180 minus 3 theta side, and in the big triangle, B is the theta, 180 minus 3 theta side. Okay, so this is correct. So that means that M would be A squared over B. Plug it into here, and we get N is equal to A squared over B times C times A. So therefore, N is equal to AC over B. Okay, moving right along. We now, let's see, where can we go from here? This point, M plus N is equal to B from our diagram. So M is this guy here, A squared over B. N is this over here, AC over B, and that's equal to B. So I multiply through by B, we get A squared plus AC is equal to B squared. or A times A plus C is equal to B squared. And that relationship will help us figure out A, B, and C, because that is basically the perimeter of the triangle. Or at least that will help us. There's A, there's B, and there's C. Okay, this formula. So I think we will have to do some cases here. Let's see, A, B, C, and then the perimeter, P for perimeter. And let's see what we get. Well, if A is 1, let me go back and read this here. They have integer side lengths. That's it. That's all they tell us. Okay, it's not much. Okay, so integer side lengths, the smallest we can start with is 1. If we have 1, because we're trying to make the perimeter as small as possible. If A is 1, then I don't think this will give us any solutions, because it'll just be 1 plus C. And if C is 1, then we can't get an integer. And even if we tried, like let's say we have 1, I think if B was 2 and C was 3, let's see if that works. We have 1 times 1 plus 3 is equal to 2 squared. That actually satisfies the equation, this guy right here, but it fails the triangle inequality. And that states that if you have a triangle, 2 sides have to be greater than the third side. Otherwise, you cannot make a triangle. So that fails. Yeah. Because 1 plus 2 is equal to 3. It's not. Okay, so let's keep going. Let's try A equals 2. And when we fiddle around with this equation here, we will get a solution 2, 4, 6. And again, that also fails the triangle inequality. And then if A is 3, we get 6 and 9. And that also fails. When A is 4, we will get 6 and 5. And that, I believe, works. Let me think about this. Yeah, that works. And I think anything after that, of course, will give you larger numbers and will give, therefore, a greater perimeter. So the first time we made it to work, as we're increasing values of A, was this. The perimeter here is 15. So that is the answer, and therefore that would be C. A right pyramid has a regular octagon A, B, C, D, E, F, G, H with side length 1 and its base and apex V. Segments AV and DV are perpendicular. What is the square of the height of the pyramid? All right, let's take this one step at a time here. Let's first draw an octagon, a regular octagon. Basically, I'm assuming that means that all sides are the same, and that is true. So we got all of them are equal to 1. And this is 3D. So this is the base, and we'll call the center of the base O. And then if this is like just flat, but there's going to be an apex if you go above O at a certain height. So I'll draw that a little bit later. I just got to set this up first. And then let's see, what are they saying? Segments A, D, oh, I got to label it. So A, B, C, D, E, F, G. And they're saying that A, V, and AD are perpendicular. Ah, okay. So let me just join AD first. So that this is you're gonna need 3D here. Okay, I'm gonna have to try to draw. First, let me draw some lines. I'm gonna draw one from O to D, and hopefully all this will kind of come together. The hard part here is just understanding this question and then making the 3D kind of drawing. And let's see here. One line from there to there. I think that's a pretty decent setup. Okay, now I've got to draw the 3D version of what's actually happening. So let me see if I can do that properly. So Okay, so this is the base, this guy, and O is sitting here, and the apex is V. So from O to V is what we're trying to figure out. That's basically the height of the pyramid. And then we have to somehow put in D and V. Okay, so how do I do that? Let me use a different color here. So let me see. Let me see here. Yeah, I'm going to try my best to make this 3D diagram, and then that will make the whole thing make sense. Yeah. It may not be drawn to scale, but at least you'll get an idea of what's going on. Okay. Okay, now that I have that in, I think that's a pretty decent diagram. Let me fill it in. So this is A right here, and it corresponds to this part. This is your D, and that I purposely, you see a small red line over on this side that I put on the diagram. I made that same red line on this diagram. They are the exact same line. It's just they're in different pictures. One is an attempt to be 3D, and the other one is just flat. This is going to be a right angle, and this angle in here is also right angle, although it doesn't look like it. So I'll just put 90 degrees sort of there. And I think that's a pretty decent setup, because I think we can do this with a whole bunch of Pythagorean theorems. Okay, so the first step we're going to need, I think, is the distance from A to D. And that should be relatively easy to figure out. So if I draw those lines, the distance is 1 from here to here. And then we need to figure out these guys, this one and that one. And that should be relatively easy. First, I need to figure out the internal angles. We have 6 times 180 divided by 8. That is the calculation for the internal angles of an octagon. So 135. So if this is 90, that means this is 45. So that triangle, let me just draw it over here because it's too small for me to fit in anything. That triangle that includes A and B, this is 45 degrees, that's 45 degrees. So that means that you can easily figure out the side lengths. It'll be 1 over root 2 and 1 over root 2. So those red lines that I drew are 1 over root 2. So from A to D is basically 1 over root 2 plus 1 over root 2, which of course is 1 plus 2 over root 2. Or if you want to write it, root 2, let's see here. Yeah, that's correct, right? Can I get a common denominator? Root 2. I think that's good enough. Yeah. Well, actually, no. This can be written as 1 plus root 2. Yeah, because 2 divided by root 2 is root 2. Okay, so that's really good. AD we got. So we got AD. So that means this is, well, there's no place for me to write it in. But this part, this midpoint, I'm going to write M. So if A to D is 1 over root 2, then if we divide it in half, it would be half of that. And I'll put that in it later if I need to. Okay, so that's really good. Now, I'm going to avoid making this diagram messy, that triangle, I'll draw again this ADV triangle. I'll draw it here. And just to be consistent, I'll put that red line that I put in down the middle like that. Okay, so that's really good. Now let's label this now. Let's see here. We have the bottom is 1 plus root 2. That's AD that we just figured out. And then the red line, whatever, I'll call it Y. And then the sides I'll call X, because it's an isosceles triangle, right? Okay, good. So, and we know that this angle is a right angle. They've actually, segments AV and DV are perpendicular. Okay, so that means that x squared plus x squared is equal to 1 plus root 2 all squared. Okay, so that makes the calculation relatively easy. And let me just see if that's correct. X squared plus x squared. Yeah. Okay, so that means 2x squared is equal to 1 plus root 2 all squared. X squared over 1 plus root 2 all squared over 2. And then just take the square root of both sides and get 1 plus root 2 over root 2. Okay, now we got that part, that piece of the puzzle. So that's good. And then what's our next step here? My next step, I think, is going to be trying to figure out, we got this x, the next step is trying to figure out that y. And once I have that y, which is basically this red line right here, then I can figure out h. But I also will need MO. This MO, where's MO? Okay, I think I see here. This is my M right there on that diagram. You see? That's M right there. This point right there. So, O to M, I think, is just going to be half of this guy. Yeah, so that's going to be just a half. That's very helpful. That's a quick calculation. So yeah, as soon as I get y, I can figure out this h with Pythagoras. So that's my next step. And I'll do it, figure out y on this triangle. So y squared, since this is a right angle, plus AD over 2 squared is equal to x squared. So that should be what helps us. So we have y squared, AD, where's AD? Well, this is AD, so it'll be 1 plus root 2 over 2. I forgot to square that. And then x squared, well, x squared is right here. So let me just plug it in. 1 over root 2 all squared over 2. Yeah. 1 over, yeah, let me just see if I did that properly. I did. Okay, so now I'm going to do this algebra here. I'm probably going to need some space, so I'm going to start over here. So we have y squared plus, let's see here. Well, let me just expand it. 1 plus 2 root 2 plus 2 all over 2, and then minus where was it? Oh, minus this guy. So that's going to be 1 plus 2 root 2 plus 2 all over 4. Is that right? I hope so. Okay, so let's see here. Y squared, therefore, is... Let's multiply through by 4, because I hate those fractions. So that's going to be 2... sorry, it's going to be 3 times 2. Yeah. 3 times 2, which is 6. And then plus 4 root 2. Yeah. And then, let's see here. Then we're going to multiply through. Then that just becomes minus 1. Or sorry, it was 1 plus 3, so minus 3 minus 2 root 2. So this is just going to be 3 plus 2 root 2. 3 plus 2 root 2. And then finally, if you divide through by 4, it'll be 3 over 4 plus root 2 over 2. Okay. We got the y squared. So now we just go back to this guy. And just in case you've sort of forgotten what I'm going to be using, it's that triangle where this is V, this is O, this is a right angle, this is M, and this is my Y, this is my half, and this is my H. So using that, we have h squared is equal to oh sorry, 8 squared plus a half squared is equal to y squared. And y squared we just calculated, so it would be 3 over 4 plus root 2 over 2. All right. Feels good when you're in the final stretch here. So h squared would be 3 over 4 minus a quarter plus root 2 over 2. h squared therefore is a half plus root 2 over 2. And that is 1 plus root 2 over 2. And they actually wanted the square of the height. So that's exactly what I found. 1 plus root 2 over 2. And that's B for the square of the height. What is the number of ordered pairs ABC of positive integers with A less than or equal to B, less than or equal to C, less than or equal to 9, such that there exists a non-degenerate triangle, triangle ABC, with an interior in radius, for which A, B, and C are the lengths of the altitudes from A to BC, B to AC, and C to AB, respectively. Recall that the in radius of a triangle is the radius of the largest possible circle that can be inscribed in the triangle. Let us first put in the parameters so we don't forget. That is A, B, and C. And I'll try to give a little bit of a primer in case you forgot. So let's say you have a circle that's inscribed inside a triangle and has the radius r, like that. Well, there's a formula that says the area of that circle is equal to r times s. Now, s is the perimeter divided by 2. So, for example, if you had x, y, and z as the sides, it would be r times x plus y plus z over 2. Got it? Okay, and then another diagram I need to draw is, let's say you have a triangle and you drew what are they called? Bisectors. Not angle bisectors, but perpendicular bisectors. So, actually, no, they're not perpendicular. Or, hold on, let me think about this for a second. Yeah, they are. So, let me just draw it. So, there's a perpendicular, and there's a perpendicular, right? That's the point I'm trying to get at. And then let's label this. Let's just give it the same x, y, z. And then I'm going to label those perpendicular lines that I drew. Let's just call it this one A, that line. And then this line here I'll call B. And then the one that top to bottom one I'll call C. And then what we're going to do is we're going to compare areas using both of these kind of scenarios. Scenario 1 on the left, scenario 2 on the right. Okay, so from this guy over here, the area of that triangle could be 1/2 base times height, where the base is x and the height is c. Or the area could be 1/2 base times height, where the base is y and the height is a. Or you could have a 1/2 zb situation. And if you modify these, you will get the following. Let's see here. A xc, right? So, so you get x 2a over c is equal to x, and y is equal to 2a big A over small a, and then z would be equal to 2a over b. I hope that's correct. And then what we'll do is substitute that into this guy. So that means the area can be written as r, which is the radius, times x, which is 2a over c, plus y, which is 2a over a, plus z, which is 2a over b. And don't forget that 2 there. And the a is the area, right? These a's. So that this a is also a. So if I multiply through by 2, this 2 comes out here, and then we're just left with 2a over c plus 2a over a plus 2a over b. And then you can divide through by 2a, and then you just get 1 over r is equal to 1 over c plus 1 over a plus 1 over b. And that basically helps us solve this question. Now we can just use this formula and trial and error to kind of come up with some ordered triples. The good news is that we have this, so that limits us, which is good. And you can see the answer choices are pretty small. So, okay, let's see. What happens? So we're going to do this case by case. Do they give us anything about the radius? They just tell us that it's an integer. And that's it. Okay. Yeah, that's all they give us. So I thought they'd help us out a little bit more, but they don't. Okay, no problem. So let's start with r equals 1, since that's the smallest integer. That means this equation becomes 1 over a plus 1 over b plus 1 over c is 1. And the parameters, let's put those in because that's important. We have to stay within these parameters. The only solution here would be a, b, c equal to, I think, 3, 3, 3, right? Yeah, 3, 3, 3. Okay, so we got 1. How about if r equals 2? Then 2 is equal to 1 over a plus 1 over b plus 1 over c. And here, the solution, I believe, would be 6, 6, 6. Yeah, because it would be then 1 over 6 plus 1 over 6 over 1 over 6. Oh, sorry, this should be 1 over 2. Sorry about that. It should be 1 over 2. So that would be 3 over 6, which is a half. Okay, that works. So this works. R equals 3. And then also keep in mind that we're also satisfying that inequality with these triples. How about if r is 3? Then we have 1 over 3 is equal to 1 over a plus 1 over b plus 1 over c. And I think the triple that satisfies this is 9, 9, 9. And we are still within this parameters. Now if r equals 4, then we'll get values of a, b, and c that are larger than what we are allowed under those parameters. So the only ones we got were these 3, and therefore 3 is the answer. 3 ordered triples, and that would be, and the answer choice is B.